Statsproblems.com was used to create this tutorial, which can help us calculate a complete independent measures t-test. Let's begin by selecting one of the 25 example problems. The question appears in the blue box. A set of population scores is normally distributed. Sample scores are from two unrelated groups. Scores in Group 1 are 85, 73, 73, 79, and 85. Scores in Group 2 are 58, 64, 73, and 61. Alpha is 0.05. Number of tails is 2. What are the results of the hypothesis test comparing the sample means of the two groups to each other? Let's step through the solution by clicking on the Next Step button. In Step 1, we calculate the mean, x bar 1, and variance of Group 1, S1 squared. X bar 1 equals the sum of x1, divided by the sample size of Group 1, N1. In this example, x bar 1 equals 85 plus 73 plus 73 plus 79 plus 85 divided by N1, 5, which works out to 395 divided by 5, which works out to 79. The sum of squares, SS1, equals the sum of the squared deviations of each score x from the group mean, x bar 1. In this example, the sum of squares, SS1, equals 85 minus 79 squared plus 73 minus 79 squared plus 73 minus 79 squared plus 79 minus 79 squared plus 85 minus 79 squared. This works out to 6 squared plus minus 6 squared plus minus 6 squared plus 0 squared plus 6 squared, which works out to 36 plus 36 plus 36 plus 0 plus 36, which works out to 144. The variance of Group 1, S1 squared, equals the sum of squares, SS1, divided by the sample size of Group 1, N1, minus 1. In this example, S1 squared equals 144 divided by 4, which works out to 36. In Step 2, we calculate the mean, x bar 2, and variance of Group 2, S2 squared. X bar 2 equals the sum of x2, divided by the sample size of Group 2, N2. In this example, x bar 2 equals 58 plus 64 plus 73 plus 61 divided by N2, 4, which works out to 256 divided by 4, which works out to 64. The sum of squares, SS2, equals the sum of the squared deviations of each score x from the group mean, x bar 2. In this example, the sum of squares, SS2, equals 58 minus 64, squared, plus 64 minus 64, squared, plus 73 minus 64, squared, plus 61 minus 64, squared. This works out to minus 6 squared, plus 0 squared, plus 9 squared, plus minus 3 squared, which works out to 36 plus 0 plus 81 plus 9, which works out to 126. The variance of Group 2, S2 squared, equals the sum of squares, SS2, divided by the sample size of Group 2, N2, minus 1. In this example, S2 squared equals 126 divided by 3, which works out to 42. In Step 3, we calculate the pooled variance, S squared pooled. First, we calculate the degrees of freedom for the two groups. Degrees of freedom for Group 1, DF1, equals sample size of Group 1, N1, minus 1 is equal to 5 minus 1 is equal to 4. Degrees of freedom for Group 2, DF2, equals sample size of Group 2, N2, minus 1 is equal to 4 minus 1 is equal to 3. Now we calculate S squared pooled. S squared pooled equals variance of Group 1, S1 squared, times the degrees of freedom for Group 1, DF1, plus variance of Group 2, S2 squared, times the degrees of freedom for Group 2, DF2, divided by df1 plus df2. In this example, s squared pooled equals 36 times 4 plus 42 times 3 divided by 4 plus 3, which works out to 144 plus 126 divided by 7, which works out to 270 divided by 7, which works out to 38.571. In step 4, we calculate the difference of the means, x bar 2 minus x bar 1. In this example, the difference of the means, x bar 2 minus x bar 1, equals 64 minus 79, which works out to minus 15. In step 5, we calculate the estimated standard error of the difference of the means. The estimated standard error of the difference of the means, s sub x bar 2 minus x bar 1, is equal to the square root of s squared pooled divided by the sample size of group 1, n1, plus s squared pooled divided by the sample size of group 2, n2. In this example, s sub x bar 2 minus x bar 1 is equal to the square root of 38.571 divided by 5 plus 38.571 divided by 4, which works out to the square root of 7.714 plus 9.643, which works out to the square root of 17.357, which works out to 4.166. In step 6, we calculate the t-value of the difference of the means. The t-value of the difference of the means is equal to the difference of the means, x bar 2, minus x bar 1, divided by the estimated standard error of the difference of the means, s sub x bar 2 minus x bar 1. In this example, the t-value of the difference of the means is equal to minus 15 divided by 4.166, which works out to minus 3.601. In step 7, we find the critical t-values. There is no previous evidence or previous evidence is inconclusive. The rejection regions are below the negative critical value in the lower tail and above the positive critical value in the upper tail. We need degrees of freedom to look up the t-critical value. Degrees of freedom total, df tot, equals the degrees of freedom from both groups added together, which is df1 plus df2, which is 4 plus 3, which works out to 7. With tails equals 2 and alpha equals 0.05, we need to look up the critical value for df equals 7. Use interactive table 7 to find the critical value. With 2 tails and alpha equals 0.05, and df equals 7, use t equals 2.365 from the lookup table. We close this window to return to the analysis, which shows that the negative critical value is minus 2.365 and the positive critical value is 2.365 with 2 tails and alpha equals 0.05. In step 8, we test the hypothesis. The t-value of the difference of the means, minus 3.601, is less than the negative critical value of minus 2.365, so we reject the null hypothesis. In addition to the 25 example problems, we can work step by step through an unlimited number of new problems using the Generate button. The Edit Data button can help us create problems with customized input. Instructors can use this function to create problems with complete solutions to use on exams, in class, or for homework. For printed output, we can print the question. Or we can print the question with the complete solution. The free website has statistical analyses in all of the most common areas in statistics. Statsproblems.com also has a mobile version so you can access the site from anywhere. For help with statistical concepts, HelpMeWithStats.com is a free website that has more than 70 tutorials, as videos, or as self-paced slideshows. In addition, HelpMeWithStats.com gives you free access to a comprehensive stats textbook with more than 685 review questions. Thanks for watching. If you find these resources valuable, please share Statsproblems.com and HelpMeWithStats.com with your friends and instructors.